让我难过。
看一片一片花开花又落，我依然执着地爱着。
在经过浪漫红尘的诱惑，人在大风雨难割舍。我们的爱情就像点点的星火，你无时无刻不在温暖我。
真心的相爱，不怕刀山来阻隔，有你在身边就快乐。
CMSCAPP 1523 by 940 mm iron bed inclined welding teaching. This is the big iron bed. The tool at the original positions. The right button of the iron bed located at the original position. We set the big iron bed just similar to the smaller one. The top surface of the bar is equal to Z37 as well. The plate surface at Z equal to 12. The bottom of the plate at Z equal to 0. The square bar right now with 4 inclined 45 degrees. We'll have to incline the tool. Well, here, like the welding, until we're to here. The bottom surface of this 4 surrounding big bar is at Z equal to -1. Let's see the drawing. This is original position. This is X directions, 1523. This is Y direction, 940. The plate thickness 12, but this bar with 1 millimeters, so this surface at Z equal to -1. The side bar is 50, so the top surface is equal to Z 49. The plate, these two sidebar with height 38. The top surface is at Z 37, and the bottom surface at Z equal to -1. So the welding all the same like the small bed. This is the typical demonstrations of the small iron bed, linear welding at this side and the other side. Right now we have 4. We have duplicate 1 to 4 welding, and then the plate with the sidebar with 2-point welding. We locate these points distance with the edge 10 millimeter, and from this point to the edge 10 millimeters, and the corner with two welding, and this one with one welding. Okay, we concentrate on teaching how to manage the spot welding and the linear welding as well. So we started from, suppose, teaching the welding from two spot welding from here to here, and then from here linear welding to here, and linear welding to there, and zigzag going around at the last to here, and continue the spot welding from here to here, and ending the demonstrations. So we continue, started from here to where to here. The first teaching how to locate a tool at these points. We change the modes to teach more, and use add one last to use K value 7. K value 7 is locate the tool with the location using Cartesian coordinate system. That means the tool tip position. To here, we just put the tool here first. The plate thickness is 12. The bottom of the tool, the plate is Z equal to 0. So the surface of the plate at Z equal to 12. The XY, we just check the engineer drawing to get the coordinates. This position here is original. So we find the X first. From here, 25 and 282.1 and half of 25. That means the X distance equal to 282.1 at 25 to get 307.1, and add half 25, that means add 12.5. 307.1 plus 12.5 to get 319.6. It is minus direction, so we write down here minus 319.6. So how much about the Y coordinates? To check the engineer drawing. From these points to get Y, is better subtract the whole width, 940. Subtract 50, subtract 25, subtract 67.5, and subtract 10 to get the Y value. So 940 minus 75 to get 865. 865 minus 67.5 to get 797.5, and then subtract 10 to get 787.5. So in here we put Y in plus 787.5 and OK. the system will locate the tool at this point. Right now, we'll turn the tool inclined this direction. So where is the direction of the green arrow? The red arrow is the same as the tool, point down. So the green arrow point to Y plus. So the thumb of the right hand point the same direction as the green arrow. The four fingers turning the positive direction. That's the reason why we have to change to Cartesian coordinate system and use RY plus once, twice to turn the tool inclined toward the right side. The square inclined 45 degrees, so we have to incline the tool with the angle with the horizontal. The tool and the angle between the tool and the horizontal shall be 22.5 degrees. That's the reason why we have to continue press RY plus until to see 157.5. Then totally is 180 minus 157.5 to get 22.5 degrees with the horizontal. So we still have to continue pressing, to continue incline the tool. We lower the speed to plus 100. Continue. 151, 152, 153, 154, 155, 156, 157. Okay, 0.5 more. We lower the speeds to plus 10. Continue press RY plus 1, 2, 3, 4, 5. So right now 157.5 degrees to get these points, and this inclined tool situation is what we want to weld these points. But we have to retract back to put the speed 1000 maximum speed, and retract the tool. Suppose twice, once, twice. Twice seems not enough, since the tool should be lower vertically to avoid to touch the edge of this sides. So we continue to press S minus. This position seems better. So 3 retract S minus. We want to get these coordinates. To lock these points, we cancel the K7 first by using renew. Cancel it. And in our system, we lock the join position. The join position is the model's position, is what we control the machine to use. So we have to change CCS to join modes and use light to lock the first point, and then change it to Cartesian coordinate system and use S plus once, twice, third times. You can see until the Z equal to 12. Then change to join mode and use light to lock the second point. After the second point's welding, the tool will retract back to the position 1. So we use head, move to position 1, and use add 1 last, get machine coordinates, the current position, and change the K from 1 to 8, and give the cutting speeds 100 millimeter per second. Then the third point created, we can run to use visual to see the script. It seems okay. Then we have to add something at the front and the rear to lower the tool vertically and incline it in. How to do it? We just use head, move to the index to the first line, and use the insert to insert one line. The first line and the second line all the same, the data, and then change the coordinates to let the y-axis vertical. This point don't move, just turning. Then we have to use Cartesian coordinate system. We have to change RY to 90 degrees, 157 to 90. We have to use RY minus once, 147, twice, 137, 127, 117.5, and press another one. Right now, 97.5. Lower the speed and continue press RY minus 92, 91, 90, and lower the speeds and continue RY minus, and one more, 90 degrees already. Then we have to change the first line data with the machine coordinates. Just use modify to get machine coordinates and press OK. The first line be changed. Then use add one last, get the machine coordinates and change the K value to 8 and give cutting speeds 100 millimeter per second, and then we can get 5 instructions in the data area. You can see the Z height is 23.477. If we retract up 10 millimeters, it becomes 33.477. So I intend to retract toward the Z positive 20 degrees in Cartesian coordinates. The tool already vertically, so we can change to join more to let the system running to multiply 1000 speeds, maximum speeds, and use Z3 plus to lift the tool 20 millimeters high. Simply press J3 plus twice, twice. Okay. Then join more already. But we right now at the button, so we have to go back to the head, move to the head first, and then lift the, and then insert one line in front, and then lift J3 plus twice, and use modify to replace the first point, and OK, and use add one last, get machine coordinates and change K1 to K8 and give speeds 100. Okay, then 7 instructions already. Let's run and have a look. It seems okay. Then we have duplicate another one at this side with 10 millimeter distance with the edge. So the totally is 37 white. Subtract 10 at this side, subtract 10 at this side. So the moving distance, it should be 17 in minus positions. Then we use set arrays. The S direction number 1, the Z direction number 1, the Y direction be 2. We duplicate 1. The X distance 0, the Z distance 0, the Y distance we calculate already, minus 17. Okay, so we have 2 spot welding. Let's run to see it. Okay. But we are welding from the very end to here right now with 10 millimeters. So how can we alter? Shift the first line with Y, add Y10. The better to see how much we have in the data field. The total line number is 14. If we cancel the last 7, then we get the first one, and then use this function to shift the first one toward the Y plus 10 millimeters. That's it. So we move to the head and use next to see the 7, and then to the 8. To remove the 8 to the end, just use DDO. Then we left 7 on the screen. The 7 we have to shift 10 millimeter. How to shift? Still use set array 2 in Y direction. Shift 10 at a positive direction. Okay, and then we cancel the front 7 points. Right now at the first points we move to it. How to cancel the first 7 at the first line? Just press the delete key for 7 times. 1, 3, 1, 2, 3, 4, 5, 6, 7. And to see the end 7 and run it, it's okay. And add H, everything seems correct. Then we have shift this toolpath minus 37 to get the other size at the H welding. By choose set arrays, and the Y direction give 2 as well, but the Y distance give minus 37. Okay, then we can see spot welding at the first edge and spot welding at the second edge. If we go to these points and don't retract the tool and continue to move horizontally to these points, then we can get linear welding. Now how can we achieve it? Right now, in the first line, use move tool to the first points, and put the cursor at the right half of the next record. Press 1, then we can shift the index to the line 7, line 2, and move to the line 2. You can see the position in here, and line 3, and move to. You can see the line 3 just turning the tool in inclined direction, and the line 4, and move to. Okay, the line 4 is the welding position, so we know the line 1 to line 3 is the leading, the rest 3 is the retract. So 5, 6, 7, if we remove it and then remove the next one, 3, then the tool will stay in these points. So the 5, 6 started from the line 5. We have to remove 6 lights. So we move to the line 5 and achieve 5, actually 6 delete. 1, 2, 3, 4, 5, 6. After 6 points removed, if this coordinates is inclined welding to the edge, then we get the right data. Then we use move tool to see, okay, the tool located at this line, and incline the tool welding. So we see visually to see the script in the data field running okay or not. It's very hard to tell from the digital value. It's better to see the system provides the tool path simulations to see the tool cutting in 3D simulation. This is what we call visual script. The achievements of visual script just run. You can see the tool from here and here inclined and linear welding to here. Let's see again. Okay, it seems okay. After this finished, then we can duplicate this tool path 7 times until the last to here. How to do it? Just choose set a rate, the right direction, change 2 to 7, and how much for the cycle period in y distance. Let's check the engineer drawing. From here to here is 66 plus 37 makes 103. So in here we have to give minus direction 103. Okay. You can see the tool started from here and linear welding the second, the third, the fourth, the fifth, the sixth, and the seventh, and the last retract to these positions vertically at Z 43.477. Right, this finished. Then we have to do the other side. We have to save this data first. How to save? Use save CC and give a file name. Suppose test 420. enter. Then the data in the data field be saved into test420.cc. Then we can renew the data to remove all of it. And to go to the other side, we started from these points and these points. So what is the coordinates of these points? How to continue the location of the tool tip to these points? We just use add one last. Use K7 to locate the tool tip in Cartesian coordinates. We give the z value 12 first, and then the x coordinate and the y coordinate. So to see the join, this point, how much for y value? The y value is 50 plus 25 plus 675. 50 plus 25 makes 75. 75 plus 67.5 makes 142.5. So the y value with feeding 142.5. And how much for the x distance? Let's see the join. This point, x direction. This is 25. This is 22.1 and half of 25. So 282.1 plus 25 makes 307.1. 307.1 plus 12.5 to get 319.6. So x must be minus 319.6. Okay, the tool located at these points. Then we have to lower the tool towards the left side. The right finger of the sun pointed to the same direction of the green arrow. So we have to turn Ry minus. Suppose in Cartesian coordinate system, this point don't move. Ry minus. We have to turn the tool inclined the axis of the tool with the horizontal, the gap with 22.5 degrees. So we continue to press until Ry, you can see here, 22.5. We lower the speeds and continue to press. Okay, 22 already. We lower the speeds. 22.7, 22.6. Okay, right now it's 22.5. This inclined tool, this position is the welding position. Then we have to recheck. We set the speed to maximum. Recheck, use x minus once, twice, third times. This position seems okay if lower the tool vertically. So we have to lock the first point in these positions. We have to remove the K7 first. Use renew to remove the data in the data field, and change to join more, and use line to lock this coordinate as first line, first instruction, and then change back to Cartesian coordinates and use S plus. To thrust the tool in to Z equal to 12 at the welding position, and change the coordinate system to join more, and lock the second points. The third points will retract to the first point positions, so we use head to move to the first points, and these coordinates in here we use add 1 last, get the machine coordinates, and change the K1 to K8, and the speeds give 100 millimeter per second. Okay, then the third instructions locked. Just run visually to see the welding, spot welding, okay or not. Okay, right now seems okay. Then we have to add something in front at the rear to let the tool lower vertically and incline thrust in. How to insert something in front? Change the position to the first line, and then insert one line in first line. The first line and the second line the same, and turn the tool vertically. Change the mode to Cartesian coordinates. Right now RY22, we have to use RY plus to adjust the tool to 90 degrees. Right now 83, 82, we lower the speeds to 100, and RY plus press once. 83.5, 84, 85, 87, 88, 89. So we lower the speeds again. 89.6, 0.7, 0.8, 0.9, 90 degrees. Right now the tool locate vertically, and change the coordinate into join mode, and use modify to get coordinate, machine coordinates. Okay, the first line be altered. Then we have to copy the line append at the rear. Use add 1 last, get the machine coordinates, change the K value from 1 to 8, change the cutting speeds to 100. Okay, right now the tool locate at Z equal to 23. These points higher than 37, so we have to lift in Y direction for twice. So we move to the first line first, and insert 1 extra lights in front. The 1 and the 2 that are all the same. Change to the fastest speed first. How to retract? In join mode by pressing J3 plus twice, once, twice, and then modify, replace the first line. Okay, and this coordinate append 1 at the rear. Use A1 at last, get the coordinate, machine coordinates, and the K give value, give 8. The cutting speed give 100. Okay, totally 7 instructions on data field. Let's run to see the cutting, spot welding. It seems okay. Then we have duplicate to another edge of this plate. How to do it? Just choose set array function. The y direction give 2. The value give the plate thickness, the plate width. The plate width is 37. Okay. Oh. Okay, no problem. Let's run it. The first point, the second point. But right now it's 2 spot welding. We have to use inclined linear welding. The same, we move to the first line, and move to the second line, and move to the second line position, and set the index to the line 3rd, and move to the line 3rd. The third line is turning the tool inclined, and move to the line 4th, and move to. You can see the line 4th is the starting spot welding. This tells us the line 1 to line 3 is the leading tool path, while the 5, 6, 7 is retracting tool path, similar with 1, 2, 3. So 5, 6, 7 has to remove, and the second 3 has to remove as well. So the line 5, starting from line 5, totally 6 lines has to remove to get linear welding along y positive direction. So we move 1 down to line 5 and delete 6 records by pressing delete key 6 times. 1, 2, 3, 4, 5, 6. After 6 instruction delete, if we use move 2 to see this position at the edge and the inclined, then we get the right data already. So we press move 2. Okay, it seems okay. The tool inclined locate at the end position. Then we see visually move the tool to the first position first, and then roll it to see the inclined linear welding to the end. We see it again. It seems okay. Then we have to duplicate 7 times along y direction by set arrays. Change it to y direction, change it to 7, and give the interval 103 millimeters in y distance. Okay, then that's it. Okay, after we get it, we have to move the data to the first line, and then insert test 420 before the line number 1. How to insert? To put the index at the line number 1 already. The tool locate at the line number 1 already. Simply by press insert file and choose test 420. 420 here. Test 420. Pick 420. That's it. You can see to here, the tool go to here, and then to go to here. At last, 6 here. Okay, this is both sides of 1 square bar. We have this root for 4 square bars, so we have to duplicate the data area 4 times along x direction by set array. The y direction, this case equivalent to 1. The y x direction equivalent to 4 times. The y distance gives 0. So how much for x distance? Definitely it is minus direction. And to check the engineer join, from here to here, how much? This is 269.6 at 12.2, 12.5, here 12.5. That's 269.6 plus 25 makes 294.6. Okay, 294.6 minus 294.6. Okay, then you can see duplicate. At last the tool stopped at here. Then we save again. Save CC. Give the file name the same like previous test 420 and press enter. Then we do the welding, spot welding at the right hand first. Use renew to remove the data here. We go this way and continue to link to here. So we started from these points. Spot welding with 10 millimeters from the edge. So add 1 last. Give K value 7. The plate heights at Z 12. And from here to here 25. This is x direction. It is x minus 25. So how much for y coordinate to check the engineer join? These points to see the here is better. 50 plus 25 makes 75 plus 67.5. 67.5 makes 142.5 plus 10 makes 152.5. In here we have to type 152.5. Okay, you can see the tool in position. Then we lower the tool, turning along y minus. Use Cartesian coordinate system 30 degrees by press ry minus 3 times. 1, 2, 3, and we check x minus 3 times. 1, 2, 3. And these points is what we need in join mode. Remove the delta K7 first and lock the first line, and then change to Cartesian coordinates and s plus 1, 2, 3, and then change to join mode and lock the second points. The third points return to the location just like the first points. So we move to the head to the first line position and use add 1 last. get the machine coordinates, change the K value to 8. The cutting speeds give 100. Okay, the third instructions created, then run to see it's okay. Then we have to change to the head, move to the first line, and insert one light in front, and change to the CCS Cartesian coordinate system, and let the tool locate vertically. You have turn RY plus once, twice, 3 times. You can see RY 90 degrees radius. The tool locate vertically. Then we have to use modify to get machine coordinates okay, to change the first instructions, and then add 1 at the last. Get the machine coordinates, give the K value 8, give the cutting speed 100 millimeter per second. Okay, and then change to the head and move to the head and insert 1 light in front and change to join mode and lift. Suppose 10 millimeters. Use J3 plus, add 1 and modify. Get the machine coordinates okay, and duplicate the line number append at the rear. Use add 1 last. Get machine coordinates, give the K value 8, K8. The cutting speeds 100 millimeter per second. Right now 7 lights created, and I run to see it. It seems okay. Then we have to duplicate to another size with 10 millimeters to the edge. The total width of the plate is 37. Subtract 10 in this size, subtract 10 at that size to get 17. So we duplicate with plus 17. Okay, how to do it? You set a rate. The S direction change to 1. The Y direction give 2. The S distance give 0. The Y distance give positive 17. Okay, then we get 2 spar welding. Let's run to see it. First one and the second one. Okay, then we duplicate this plate to 7 to the last one. Simply by choose set a rate. The Y direction give 7. The interval we know already, 103. Okay, then duplicate to here. Then we can run to see it. First one, second play, third play, fourth play, 2 spar welding, fifth play, sixth play, the last play. Okay, then we have to append test 420.cc at the rear of the data in the data field. How can we do it? Simply by use head tail to choose to put the data index at the tail. You cannot insert file these moments. You have to lower 1 line to 99 and then insert file to choose test 420. Test 420 here. Pick it and save file. You can see from here is 10 to here, and continue to go to the real. at last stop here. Then we have to save and then to do it this line. Okay, save CC. We use the same file name, test 420, and press enter, and use renew to remove the data here. And then we start welding from here to go this direction. But add one last, give K value 7, the plate height at Z equal to 12. And what is the coordinate of X and Y? We survey from the drawing. This position, the accelerations use 1523 subtract 25 is better, quicker to find the X coordinates. 1498 in minus, so X equal to minus 1498 millimeters. So how much for the Y? The Y coordinates is better to calculate from here. Here is 940. 940 subtract 50, subtract 25, subtract 67.5, subtract 10 to get the coordinates. So 940 subtract 75 to get 865. 865 subtract 67.5 to get 797.5, and then subtract 10 to get 787.5. So here 787.5. Okay, you can see the tool located here, and then we turn RY plus 30 degrees, changing the mode to C Cartesian, and press RY plus 3 times, 1, 2, 3, to get the inclined tool, the welding points, and then we check for 3 times, S minus 1, 2, 3. This is coordinate what we want to lock for the instruction 1. We remove the K7 first by pressing renew, and then change the coordinates to join mode, and lock the first points, and change to Cartesian again, and press S plus 1, 2, 3 times, and then change to join mode and lock the second points. The third points will retract back to the first point's positions. We change head to tail, change to head, and move to the head to the first point lies positions, and use the add one at last. Get the machine coordinates. K value give 8. The cutting speeds give 100, and OK to lock the first welding, and run to seal it. It seems OK, and the head move to the first line, and insert one in front, and change to Cartesian coordinate system, and to let the tool locate vertically, and use RY minus, press once, twice, 3 times. You can see RY equivalent to 90 degrees vertically. Then we use modify to replace the line number 1's current position by using get machine coordinates. OK, so the vertical positions in line number 1, and append line number 1 at real, use add 1 at list, get the machine coordinates, give k value 8, and cutting speeds, give 100 millimeter per second. Okay, that's it. And change to the line number 1 and insert one line again, and change the coordinate to join more, and leave the coordinate once with 10 millimeters lift height. And in join more already modify the first line to get the machine coordinates. Okay, the first line positions similar to the machine coordinates, and then append the first line at the real, get the machine coordinates, give k value 8, the cutting speed give 100. Okay, then 7 lines created, then run to see it. It seems okay. It's okay. Then we duplicate another one, move minus 17, set array, the y direction give 2, the y distance give minus 17. Okay, then run it, spark welding once, twice. Okay, then duplicate 7 times, set a rate, the y direction 7, the y distance gives minus 103. Okay, at the last, the tool locate vertically at the highest positions at here. Then how can we insert the test 420 in front of the data area? Simply to put the index at the number 1 and the move tool to the number 1. In this position, just use insert file and choose the test 420. Test 420 and pick it, and OK. You can see in here it tend to here, and at last stop here. Suppose we only have this data for welding, then we have, for safe reason, we save CC file first. The file name test 420. Okay. Suppose for water jets, the first line we have to open water, open sand. For the last one, we have to close water, close sand. The same for CO2 welding or arc welding. The same, we have to set the first line to K6. The last one set K10. So right now, in line number 1, we move to the number 1 and modify to change the K8 into the K6. So the first line become K6, and you choose the tail, move to the tail. The tail line is 644. The same, use modify to change A to 10. Okay, the last line become change the K10. The arc welding will cease the power. Okay, let's running the data in here. Then we just run to see the 3D simulations and ending the demonstration.
真心的相爱不
出一幅天亮和地空。
真心的相爱，不怕祸害来折磨，我们就是最美的景色。
手抱紧我，说不会再让我难过。
看一遍一遍花开花又落，我依然执着地爱着。
再经过浪漫红尘的诱惑，任再大风雨难割舍。我们的爱情就像点点的星火，你无时无刻不在温暖我。
真心的相爱，不怕高山来阻隔，有你在身边就快乐。
我们的爱情就像熊熊的烈火，它烧出一幅天亮和地空。
真心的相爱，不怕祸害来折磨，我们就是最美的景色。
我们的爱情就像点点的星火，你无时无刻不在温暖我。
真心的相爱，不怕高山来阻隔，有你在身边就快乐。
我们的爱情就像熊熊的烈火，它烧出一幅天亮和地空。
真心的相爱，不怕祸害来折磨，我们就是最美的景色。